Okay, welcome to my video on arrays. So we'll get going. Essentially, an array, as in C#, C++, Visual Basic, is just a series of memory locations, contiguous. In other words, there's no spaces in between. It's back to back. That store multiple values that are associated with one name, unlike a scalar variable, where you have to have a separate name for every memory location. And that makes it pretty convenient for several reasons. One is you can have more flexibility, and two is you can dynamically size these things upon runtime based on some outside criteria, like how many records are in a database, where you don't have to know how big it is. You just automatically allocate it based on the number of elements that you need. So let's take a look. Okay, this is something you saw earlier in strings, because in C#, strings sort of are like a single-dimensional arrays. We're going to be looking at single and multi-dimensional arrays shortly, but let's just look at this definition I have here. A string, or an array in this case, is simply a memory location whose hexadecimal address points to the name given by the array object when it's declared by your program. Okay, so just like a scalar variable, you can have one location that has one value, but in a string it's multiple locations. Of course, they're all back to back. So really, in a sense, a string is nothing more than a single dimensional array. And you can see the index or ordinal position at element 1 or index 0 I have a T. At element 2 or index 1 I have an O and then an M. Now notice there are 3 characters or 3 elements in this array. TOM, that's 3. However, the highest index is always 1 less than the number of elements. That's a little rule you should probably try to remember. Because 0 is a number, if you count the number of digits for the index, you'll see that we have 0, 1, and 2. Well, that's 3 digits because we have 3 elements. However, since we started with 0, we won't go to 3, we go to 2. That's 1 less than the number of elements. And so it says here the memory location can contain from 0 to n characters if it's a string. It can be from 0 to n integers or doubles. Doesn't matter. It depends on what data type you declare the array to be. Further, when accessing a specific element in an array, the compiler uses a technique known as relative offset addressing. It's something that's probably not in the book, but I thought you'd want to know how that works. And the reason why I'm saying that is, if you remember our previous discussions on regular variables or scalar variables, the name on the left of the assignment operator when you're declaring and initializing the variable points to the beginning hexadecimal address of memory. That's how you have access to the contents in that memory location. Well, so does an array name. It points to that first element, that first hexadecimal address. But to get to other elements, it has to do something a little bit different, because each one of those is a different memory address. So that particular technique is called relative offset addressing, and what this means is, in a scalar variable, the compiler starts at the hex address, pointing to the array, by the array name. Unlike scalar variables, however, the compiler then multiplies the index specified by the number of bytes required to store each element. So, in the example below, if element 1 needs to be accessed, you'll see the element 1 up here, right here. The compiler starts at index 0, the beginning address of memory, because that's where the array name starts. That's what it points to. So it has to start right here. Okay, that's the beginning hexadecimal address of those contiguous memory locations. All right, and then it multiplies the index, which in this case would be 1. We want to go to index 1 right here to get at element 2. Is multiplied by the index number by the number of bytes required to store each element. Well, a character occupies 1 byte in memory. If it were an integer, it'd be 4, but in this case, it's just 1. So you start here, multiply 1 by 1 byte, and then add that 1 byte to the starting address. That puts us here. If it were 2 bytes, you'd multiply 2 by a byte, and you wind up over here. If it were an integer, you'd start here, and if an integer is 4 bytes, you'd multiply 1 times 4, and that would put us right here. If it were element index 2, then you start at the starting address and multiply 2 by 4 bytes, and it put us 4, 8. That put us right here, and we'd have access to that element. That's basically how it works.